Hello, welcome to today's class. Today's class uh, will again be on the introduction part. So we are studying digital computer design in this subject, and we need to know what actually we mean by a digital system. So we'll try to contrast it with an analog system. So to start with, what is actually a digital circuit? So digital circuit is a circuit that perform operations on digital signals. So now question is, what is actually a digital signal? So digital signals are the signals which are restricted to only a few discrete values. So what do we mean by that? If you look at this figure, we see that we have a signal and it has only two possible values, which is 0 or else 1. So the signal is 0 for some amount of time, then it changes to 1, then it remains 1 for some amount of time, then it falls back to 0. So the signal can have only two possible values, 0 or 1. So this is a digital signal. Another example of a digital signal is here, and this digital signal, whereas the previous digital signal had only two discrete values, 0 and 1, this signal has four discrete values. So this is one possible value, 1 volt. The other possible value is 0.5 volt. The next possible value is minus 0.5 volt, and finally minus 1 volt. So now the signal can take four different values, and hence it cannot take infinite number of values but only a few discrete values. It still is a digital signal. In contrast to this, analog circuits perform operations on analog signals. And what do you mean by analog signals? Analog signals are signals which take a continuous range of values. So here are some examples of analog signals. So these signals can take any values between, if we are restricting between a max and a min value, it can take any possible value between that max and min. The infinite possibilities between that max and the min value. Similarly, here is another analog signal. And to give you an example, for example, if we say the temperature, the temperature is actually an analog signal, because when we say temperature, it can have infinite number of values. So for example, even between 30 degrees centigrade and 31 degrees centigrade, we can have infinite number of values. For example, 30.5 degrees centigrade or 30.55 degrees centigrade or 30.592 degrees centigrade. So like that, a signal can take infinite number of values. So such signals are analog signals. Another example may be your voltage. So voltage may be 5.5 volt or 5.55 volt or 5.92 volt and so on. So analog signals can take infinite number of values. Digital signals can take only few values, possible values, discrete values, and the circuits that operate on analog signals are called the analog circuits. The circuits that operate on the digital signals, they are called the digital circuits. Now one type of digital circuit is your binary system, where we allow only two possible values, let's say 0 and 1. For example, this is a binary signal because we have only two possible values, 0 or 1. So Now why do we use binary system is because the resultant circuits that we build are simpler and they are more reliable, and that is the reason for opting for binary systems. Maybe we can build a circuit which use this signal, which have 4 different levels, but the circuit may be little bit more complex, so having a binary system makes it more simpler. Next, let's say we have a binary digital circuit. Now how do we represent the two values 0 or 1? They are usually represented by the levels of voltage or current. So for example, the voltages may be used to represent a 0 or 1. They are called the logic levels. Now to make it clear using a diagram, so here we have the possible voltages between a low voltage and a max voltage. Between a mean and a max voltage, I can have infinite number of voltages. So what is done actually is a particular range of voltage is used to represent 0, and another range of voltage is used to represent 1, and anything in between is not acceptable. So it is not, so if you have a voltage which falls in this range, then it is neither 1 nor 0. To make it more clear, let's say the minimum voltage is 0 volt and the max volt is 5 volt. So we may say that from 0 volt up to 1.5 volt, any voltage in this range will actually represent a 0, and any voltage in this range 3.5 to 5 volt will represent 1. And if the voltage is between 1.5 to 3.5, and that is not acceptable because it's neither 0 nor 1. So as you can see, the voltage, the value of the voltage in itself is an analog signal. It can have infinite number of values. However, by creating a range for 0 and creating a range for 1, we are treating the voltage as a digital value. So this way of representing 0 and 1 is called the digital abstraction. So although the underlying voltages can have infinite number of values, but by creating a range of values for 0 and 1, we abstract the infinite number of values that is possible in this range as 1, and infinite number of values that is possible in this range as 0. So this way of representing is called the digital abstraction. And now what may happen is, in positive logic system, the logic 0, the 0 is represented by the low voltage level and 1 is represented by the high voltage level. That is, when the representation is something like this, it is called a positive logic system. However, it may be that we use this range from 0 volt to 1.5 volt, we use it to represent 1, and then we use 3.5 volt to 5 volt to represent 0. Such a representation is called a negative logic system. So we have negative logic system when logic 0 is represented by the high voltage levels and logic 1 is represented by the low voltage levels. So this is all that I have for this class. We will meet again in the next class. We'll talk about the binary number system shortly, and maybe also about the different logic gates. Until then, I'll end my class today. So see you again. Bye.